So good afternoon everyone. This is my oral recitation in trigonometry. So what is trigonometry? Trigonometry comes from the Greek word trigonon, means triangle, and metron, which means to measure. So trigonometry is a branch of mathematics that deals with the relationship between the sides and angles of triangles. The study of trigonometry dates back to ancient civilizations such as the Babylonians, Egyptians, and Greeks. In Babylonian period, in 2000 to 1600 BCE, Babylonians were one of the first civilizations who studied the relationship between the angle and sides of triangles. They developed tables of values for trigonometric functions to aid in calculation. In Greek period, from 300 to 200 BC, the Greeks, particularly mathematicians like Hipparchus and Ptolemy, made significant contribution to trigonometry. They introduced the concept of trigonometric functions such as sine, cosine, and tangent. In Islamic Golden Age from 18th to 14th centuries, during this period, Islamic mathematicians like Al-Khwarizmi and Al-Batani further advanced the study of trigonometry. They introduced the use of trigonometry in astronomy and navigation. In European Renaissance from 15th to 17th century, trigonometry continued to evolve in Europe with the work of mathematicians like Regiomontanus and Copernicus. The development of trigonometric identities and the unit circle further expanded the applications of trigonometry. So next, I will discuss the importance of trigonometry. Trigonometry plays a crucial role in various fields such as mathematics, physics, engineering, and astronomy. Trigonometry helps in solving problems related to triangles and angles, making it essential in geometry and calculus. It is also used in navigation and surveying to calculate distances and angles and positions. Trigonometric functions are fundamental physics for analyzing periodic phenomena like sun waves and alternating currents. So, next I will discuss the five principles of trigonometry. First, the principle or the theorem that trigonometry has is Pythagorean theorem. So, Pythagorean theorem states that in a right angle, the square of hypotenuse is equal to the sum of the squares of the two other sides. So in mathematical terms, if A and B are the length of the two shorter sides of a right triangle, and C is the length of the hypotenuse, then the Pythagorean theorem can be written as this. So, A squared plus B squared is equals to C squared. Is the sine rule. So sine rule relates the length of the sides of a triangle to the sines of its angles. Example is refers. So we can write this as A over sine A is equals to V over sine B equals to C over sine C. Another is cosine rule. The cosine rule relates the length of the sides of the triangle to the cosine of an of its angle. In triangle with side ABC and the angle C, the cosine rule is, we can write it in this form. So C squared is equals to A squared plus B squared minus 2ab cos. We can write the angle of this side, which is c. So we can write it as c squared plus is equals to a squared plus b squared minus 2ab. This is 2 cosine c. Another is angle, sum, and different identities. These identities related to the trigonometric functions of a sum of a difference of two triangles to the trigonometric functions of the individual angles. Example of these trigonometric identities is one of the example of this is the Pythagorean identities. We can write Pythagorean identities in this. So, sine squared theta plus cosine squared theta is equals to 1. So, if we transpose this, we can write as cos squared theta is equals to 1 minus sine squared theta. If we transpose this here, we can write it as this. Next is the tangent theta. We can write tangent theta in this form. It is also the Pythagorean identities. So 1 plus tan squared theta is equals to secant theta. It is because 1 plus tan is equals to 1 over, so tan, we can write tan as sine over cos, and this one we can write is cos plus cos, and this one we can write it this, so we can equal, so cancel, so sine over cos, so this is tan, so 1 plus tan is equals to this 1 over cos, we can write it as secant theta or secant squared theta. Next is the cotangent. So cotangent we can write it as one plus cotangent theta is equals to cosecant theta, cosecant squared theta. So this one, this cotangent, we can write it as cosine over sine squared theta is equals to this also 1 over, so sine, we can write sine here, and this one, so we can, so it is sine, so we will write sine here, so sine over sine is equals to 1, cos over sine, we will write it as cotangent, and this 1 over sine is equals to cosecant theta or cosecant squared theta. Another identities is the cotangent identities. So cotangent identities, tangent and cotangent identities is just like this. So tangent tan squared theta is equals to sine sine theta sine squared theta over cosine squared theta. And cotangent is the reciprocal of this. So reciprocal of the tangent is this cosine will be in this in the numerator and this sine will be in the denominator. So we can write it like this. Cosine theta or cosine squared theta over sine squared theta. In this tangent, we can write it as sine squared theta over cosine squared theta.